Hi, so we're going to talk about what happens when you have a material that doesn't do that. So remember, what doesn't behave with Ohm's law. So Ohm originally had these materials called resistors that behaved where if he put, so you can imagine here like a resistor, if he puts a current through this, that based on their resistance would be how much potential, how much energy that resistor took away. And he ended up with this rule here. But the problem is there are components that don't behave like this, okay? So resistors, this is specifically for resistors, the thing that converts it into heat energy. There are other components in circuits which don't actually behave like that. And you need to know about a couple of them, okay? So for example, I'm going to talk about this one called a diode. Okay, so a diode is a very useful component. Okay, and a diode, I just want to make sure that I'm drawing, I just want to make sure that I'm drawing the circuit symbol correctly because I always sometimes make an error with that. Yeah, it's this way. I was wondering why I was looking, there we go. So there's your diode. Always get that circuit symbol because there's another one with a circle and then there's another one with a Zener. So I just wanted to make sure I was drawing the right circuit symbol for a few seconds. So a diode, for example, is a component which is really useful because it only lets current flow one way, okay? Its literal job is to just make sure that current can only flow in one direction. And more importantly, that current does not flow until it has enough potential across it. So these are really good safety devices. So actually, if I drew a graph of this here, and I drew current up here and potential down here, okay? It will only let current through if there is enough potential. And that potential, of course, depends on the diode. But what happens here, it goes up, and then all of a sudden, it will just let current through. It should be quite straight there, okay? So but actually, can you see here, it is not a relationship, which is a nice linear relationship. We call this the threshold voltage, by the way. This is the point in which we say that all the current is being allowed through. So what's happening is that if you had a diode in a circuit, okay, so I'm going to put a diode here, and I put a variable resistor, and I'm going to put my diode like that there, okay. So let's say this is 10 volts, okay. This would go between 0 and 10 volts, depending on how much resistance, because this will behave like ohm. So this will go V equals IR. So this will have, depending on how much resistance, will change the amount here. This will only let current through if there is enough threshold voltage across it. So for example, if the threshold voltage was 3 volts or more, okay, so or more, so it has to be at least at 3 volts. It means that when this is going between 0 and 3 volts, so if this has been adjusted, the resistance, so this has between 0 and 3 volts, it's not going to let anything through, okay? So this would have to be 7 or less voltage on there. Okay, so if that had 10 volts on, if that resistor had 10 volts on it, there wouldn't be enough voltage for the diode. So this is not behaving with Ohm's law, but it is giving us a really useful part of a circuit because it's meaning that we can control how much voltage goes to certain parts of the circuit. So if we wanted a circuit like this, so we had a light or a lamp, okay, and basically again, if I had 10 volts, let's lie and say the threshold for this was 4 volts, okay, which means that this has to be either between 0 and 6 volts, okay, because if 4 volts or more gets shared, this will have 0 to 6. What it's doing is protecting this because if this, for example, decided to have 7 volts, which might be enough to melt the light and all that, because this has 7, it was given 10, this would have 3. This would not work, okay? Which would mean that it's protecting the components. So that's a diode, okay? And you need to know that graph there. Another symbol, which is a bit strange, was actually, weirdly enough, the one I had a minute ago, which was a lamp, okay? Lamps are strange. This is a lamp. And they actually, if I drew them here, so if I draw the current and the voltage here, what happens is that when the particles in them, because they're giving off light, they actually start vibrating. So you actually do get this at the start. It does behave like a resistor. But then what happens as it gets really, really hot, the particles start vibrating a little bit more. And then what happens is that basically the resistance gets really high. Okay, and if you did it the other way as well. Ugh. Okay, so the resistance gets very, very, very high, okay, because if you can imagine the particles inside, when it's getting really, really hot, they're going to vibrate around a lot, okay, and I can tell, so you've got Ohm's law there, but then the gradient gets really steep because the resistance gets really steep, okay, so this again, it's kind of behaving a little bit with Ohm's law, but not fully. Okay, but again, engineers can understand that if they have too hot a temperature, okay, no matter that the resistance of the lamp is going to get so high that no matter how much potential you put energy in that, you won't get any difference in the actual current that's going through. Okay, so there we go. They are two components. So we've got the diode, like here, which doesn't let current through until you reach the threshold voltage, okay? And you've got a lamp, which basically, as it gets more energy in it, it will start becoming more and more and more resistance. This is current and that is voltage, okay? This is current and this is voltage. Yes. So you have no current and then all of a sudden there's a current going through. Okay, so these two components are really important components that don't follow Ohm's law, but there is a reason for that because of how the component is made. So just remember, only resistors obey Ohm's law, V equals IR. Now, sometimes what will happen in a circuit, when you're analysing circuits, is that what an engineer might do is they might arbitrarily say that this has a resistance of, let's say, 5 ohms. And normally what they're doing is either a worst case scenario or an average. So at least you can get some calculations to go, okay, and normal working conditions, this is what that value is going to be there. Okay. So there we have it. That is some basics of things that do not obey Ohm's law.